Well, hello everybody and welcome back to John's Workshop, and in this video we're going to be making a couple of drawbars for my Cormac ZX7045 import milling machine. So recently changed my spindle over from Morse Taper 4 to ISO 30, and through the course of last year received a couple of very kind viewer gifts in the shape of a up-to boring head and also a Clarkson end mill holder. Now both of those have got different threads, one each, so two different threads to the M12 thread that's on my standard drawbar, and I want to be able to use all three things. So two new drawbars to make. I've bought some EN8 high tensile, well highest tensile steel rather than just using plain old mild steel, so got some material in. So yeah, a couple of drawbars to make. I've explained about the threads. They're both imperial threads we're going to be putting on, so we'll have an imperial thread on one end and a metric 12 thread on the other end for standard M12 hardware that I've got plenty of in the shop for the top of the drawbar. So dead simple turning job, nothing too elaborate on this one. So without much more waffling, I'll quickly show you the raw materials and then we'll move over to the lathe and get on with it. Okay, so here's our raw materials. So I've got two lengths of 1/2 inch diameter EN8, so nothing much to do to that on one end, bit of turning on the other end, thread on each end, and then I've got a nut to fix to the top end, or two nuts, one captive with a roll pin and one movable, which will be the tension for the drawbar, and I've also got some 25mm EN8 that we're going to make the nuts out of. So I'm going to make proper flange nuts for the top of the drawbar out of a nice bit of EN8, and that will be what we tighten the drawbar up with. And as I said just now, two different threads, so we've got 1/2 inch UNC in one of the units that we need to fit and 1/2 inch Whitworth in the other. So two different threads to go, one on each of the drawbars. So I'll go over to the lathe now, I'll get my stock cut to length, you don't need to watch that, and I'll join you at the lathe when we're putting the first threads on. So I made an error there. We should have had that nice and tight in up against the chuck to face off, but it doesn't matter. But I am going to move it in so that I can put a nice leading chamfer in for the thread. So this one's for the Clarkson. Yep, that's lovely. There's a little bit of play in it, but for a drawbar that's absolutely fine. So what I'm going to do now is whip this out. I'm just going to run a gentle bit of file over there just to make sure there's no really sharp crests on the threads. I don't think there is, it feels okay, but I'll just clean it. And then I'm going to whip it round. I'm going to put an M12 on the other end in exactly the same way, so I'm not going to film that, you're not missing anything. It's exactly the same, using a die stock. When we come to do the second drawbar, I do have a die for the other end for the 1/2 inch BSF, no, 1/2 inch Whitworth, but the die's so big I don't have a die stock for it, so I've either got to make a die stock or we'll do a bit of screw cutting. So that's the option we're going to go down. Okay, there's our first drawbar done. So we've got our M12 on that end and our 1/2 inch UNC on that end, and I've just got my second one loaded up in the chuck, so we're just going to face that off, move it out to the right length, centre drill it, and then set up for screw cutting the 1/2 inch Whitworth. Okay, we put our revolving centre in. Because this is a Whitworth thread, we've got our 55° ground high speed steel tooling, and we've got our compound set to 27.5 degrees. So don't really need to do that. I could just be using the cross slide, but being as this is the first screw cutting I've done since probably, I don't know, the early 1990s, mid 1990s, I'm going to aim to do it properly, because why not? So I'm using my fishtail there to set my tool up so that we're square to the work, using the 55° cutout on the fishtail. So I'm just going to get this blued up now. We'll take a scratch pass and check our pitch. I've set my gearbox on the lathe to the right pitch, 13 TPI. So we'll just blue it up and take a scratch pass and see what we've got. Okay, I think I mistakenly said 13 TPI a minute ago. I'm getting mixed up with the UNC thread. 1/2 inch Whitworth is 12 TPI. So I've checked my gears. I know you can't see, it's just off screen, but I've checked I've got the right gears in the back of the headstock. And if I look at where 12 TPI is here, we've got C6TY. So if I just pan out, we're on C, we're on 6 down here on the tumbler, T and Y. So I think we've got everything set up correctly. Not only is this the first time I've screw cut since the early to mid 90s, this is also the first time I've screw cut on this lathe since I've had it. So this is a bit of a learning curve, or an adventure into the unknown. So after we've blued, I've come in and I've just touched on till we make a mark. I've zeroed my compound slide, I've zeroed my cross slide, and I've got a DTI sat on here onto my cross slide mid-range, and I've zeroed my DTI, and that's because we're going to be using the compound slide to advance the thread in the traditional screw cutting style. That's the way the books tell you to do it, and obviously having the DTI on here helps you know what your direct in-feed is, so you can gauge the depth of your thread correctly, because if you're just gauging it off your compound slide, it won't be the right number, because obviously you're going in at a skewed angle. So I always used to use a DTI, and just use the DTI to control your depth. When you've got your compound slide kicked over like this, it just makes life far easier. You can calculate it, you can actually calculate the compound angle, or not a compound angle, but you can calculate the depth by the angle and just wind into that depth on your compound slide, but that's one variable too many in all of the variables you've got when you're screw cutting. So it's far easier to just take a direct reading off the cross slide using a DTI. So I'm just going to come in, we'll take a scratch pass across there now, I'll get my thread gauges out and we'll check it for 12 TPI. So I'm leaving my half nuts engaged because this is a metric lead screw and I'm cutting an imperial thread. I'm just going to go and get my pitch gauges and we'll check that out, but it looks about right. Looks like 12 TPI to me, so we've obviously got this all set up correctly. Happy with that. So we'll start to in-feed and cut the thread. Okay, can anybody spot the deliberate mistake? I'm sure those of you that do this more regular than I do have spotted it before I even started. So two things have happened. Three things. One, I've lost the tip of the tool. I think I must have just gone a bit too far in. Two, I've balls the thread up. No other way of saying it than that. And the reason I've done that is because I've set my compound slide to the wrong angle. So I've set it to 27.5 degrees away from 0, whereas I should have set it to 27.5 degrees away from 90, and that's why I've messed all of that up. So there you go. That's what loss of memory and not doing this for 25 years does to you. All is not lost. So I've checked how deep I've actually gone in, and because this is 12.7mm or 1/2 inch bar and I need a 12mm thread on one end, I can clean this up pretty much. There might be a tiny scratch left on the top, that'll be fine. To put my M12 thread on this end, then I can whip it round, regrind my tool up and have a second go at it with the compound slide even set to the correct angle. So I will bring you back when I've rectified some of this and we're back on track. Okay, so we got out of jail on that one, so we've just got a clean up and we've got our M12 thread on that end where we messed the 1/2 inch Whitworth thread up. So back to where we were. So I'm going to get this loaded back in the other end and we shall have another go at the 1/2 inch Whitworth. Before I do that, I need to regrind my screw cutting tool because, as I said, we've broken the very tip off it. Whether that's going to show up or not, but yeah, we've just lost the tip. So a bit of tickling up to do with that. So I'll bring you back when we're back to where we were and we're starting to put the thread on the other end. So you'll be pleased to know we've now got the lathe set up correctly to put our 1/2 inch Whitworth thread on the bar. I have got no idea what was going through my mind the first time I set this up. I used to know this stuff, I used to teach this stuff to apprentices, and yeah, it's just the time in between, just not thinking, set the compound slide to the wrong angle. But not to worry, we've rescued the situation as you've just seen. So what I've done this time, I've reground the tool, so I've got a nice sharp tool again, and this time, rather than making life difficult for myself, we've put an undercut in at the base of the thread, so I've got something for the tool to run off into when we get to the end, so not risking breaking the tool. So we've got everything set. I've not changed any of the gearbox, so I know my pitch is correct. So we're going to try again. Okay, we've done a few passes off camera, just on the final spring pass now, and we're working to our numbers in terms of our thread depth on the DTI, so this should be our last cut. So I think I can leave everything engaged there, and I should just about be able to get the boring head onto the end of the threads here to check it. But that's a very nice looking thread. Yeah, that's a much happier arrangement. No play in there at all. So despite my eagerness and false start, I'm really pleased with that, considering that's the first single point screw cutting I've done for probably, I don't know how many years, it must be 25 I would think, something like that. I think we'll call that a success, don't you? Okay, we're going to move on to the shouldered nuts now. So I've got another bit of EM8 and set that out to the right then to get 2 shouldered nuts and a chucking piece for the mill. So there's our first shouldered nut complete. So I'm just going to do exactly the same to the second one. I'm already tapped through, so I'm just going to face countersink to clean the threads and pop my second one off. I'll not film that because it's exactly the same. Okay, we've got two standard M12 nuts in the vise with a bit of copper just to make sure we're gripping on both of them. They were set on a parallel, which I've now removed, and I've set my DRO up to the two places, and we're going to put a 3mm hole right the way through both sides of the nut. And I've got some 3mm roll pins, and they're going to be used to fasten these onto the end of the drawbars. So we'll get that bit done now. I'm not spot drilling, I'm just going to take my time on the way in and just blast through these for what they are. So my roll pins are a bit long, so good old Woolies Dremel to the rescue. We'll just shorten them down. That's nice. So we're going to focus. There's our roll pin, both sides nice and flush. We can take that back out should we need to, and there is our drawbar finished, and at the other end we've got our screw thread that we did for with the single point for the up to boring head, which looks very nice. So I'll get the other one done to the same standard. Okay, we've just given the mill a good clean down. So we've got our existing drawbar, the 12mm M12. We've got our 1/2 inch UNC and our 1/2 inch Whitworth. And now you can see why I went for the roll pinned kind of assembly, if you will, because that matches the original. So I've now got 3 drawbars that all look the same. They've all got exactly the same spanner fitting on all parts of this should I need it, so I've not got separate. One of my viewers suggested, and it was a really good idea, that instead of having two, you know, one with a 1/2 inch Whitworth, one with a 1/2 inch UNC, I actually just put 1/2 inch Whitworth on one end and 1/2 inch UNC on the other, and that would have worked. It was a really, you know, it's a cracking idea, not one that I'd thought of, but obviously that would have meant that the hardware at both ends would have been at some point loose, kicking around in the workshop, and I'd have just ended up losing it. So I'm pleased with what we've got. They're all 3 the same. Once I get my racking built, we'll just have a kind of sort of fork affair or whatever it is, so I can just kind of drop these in so they're hanging at the back of the mill, nice and easy to get at. So you all know that my M12 one works because you've seen that working many times, so let's have a look at the 2 new ones we've made and see whether they work. So I'll just reposition the camera and we'll try and put our our Clarkson unit that I showed at the beginning and our up to boring head in the spindle. Okay, so we'll start with the 1/2 inch Whitworth for the up to boring head. Make sure everything's clean. Oh, that's as smooth as silk, that's lovely. Superb. That now means I've got this at my disposal to use, and I'm really pleased about that. So That's one done. I'm not going to tighten them up, there's no point. If they go in that far, they tighten up okay. So that's the boring head out. We'll just switch that over. Put the 1/2 inch UNC one in. And check that with our Clarkson unit. Yep, again, superb. No bother at all. Really pleased with them, they're a really good fit. They feel a lot nicer in the spindle than the one that actually came with the mill. Probably because they're 1/2 inch OD all the way down, and this is 10mm OD all the way down the original, so it's a bit more wobbly inside the centre of the spindle. So there we go. Job's a good one. I will bring you to the board and we'll close this episode out. So there we go, that gets us to the end of our new drawbar episode with its trials and tribulations. I've enjoyed making those, actually dead simple turning job, but I have enjoyed doing some single point threading, which I've not done, as I said, for 20 some odd years, and that was obviously evident in my basic mistakes that I made. So, but you know, the thread that I did produce in the finish was really nice, not torn, not ragged. So happy, and that's the first time I've done any screw cutting on my Harrison M300. So that just goes to confirm to me that everything's right as it should be with the gear train and the gearbox and everything else. So really happy with that, and it's a 2-second changeover, and I can now use all the bits and bobs that I've got at my disposal in the milling machine. So I hope you've enjoyed that. Thank you very much for watching. Thank you to the subscribers and the new subscribers that have come along, and we'll catch you all very soon on another video when we'll be making something else.